So everybody in this room, it's probably their domain to add new functionality to a website. But what about the majority of website owners? What about that salon owner who has his daughter hack together a website for him? It starts off simple, and then he has a script tag added here, a widget, an image gallery, a couple of analytics tracking tools for some reason. So over time, this small, simple website turns into this multi-megabyte monstrosity. It's not really his fault, right? He doesn't know exactly what he's doing. He just knows the end result is going to make his website cooler. But so how can we, as the developers of this third-party embedded code, make the situation a little better? Well, before we get started, my name is John Fawcett. I work for Cloudflare. I've been building out our AMP experience. You may know Google AMP. I've also been helping out on our apps team. So I've been writing quite a bit of embedded JavaScript lately. It's been fun. So before we get started into the main thing, let's take a look at some presumably reputable survey. So according to Netcraft, back in 2016, we hit over 1 billion unique host names. And got Carl Sagan up there just for effect, right? He has nothing to do with this. And also, I added an emoji about an hour ago because everybody else seems to have them. So 1 billion host names, all right? And 72% of these pages make more than 51 requests. And we can imagine that that seems a little high. And of course, there's a bunch of pages that make way too many requests, right? So the reason I'm showing you this is just to give you perspective. We are developers and we kind of know what we're doing maybe. And the rest of the people that maybe own the rest of the billion host names on the internet probably don't know as much. So, and we should get inside of their head. How are they even adding this functionality to their website? And there's really three sort of scenarios they go through. They either know enough to be a little bit dangerous. They find a script tag on the internet, and then they just paste it into their site, and then they tweak things until it works. And then there's like CMS plugins, things like WordPress and Wix and Squarespace. Or they just like ask a developer, right? But that's us. Or maybe the developer they ask is copying and pasting as well. We're really only going to focus on these first two. Because at the end of the day, these are pretty much exactly the same. Maybe in the WordPress, you've got a few extra APIs, but these pretty much have the same constraints. What are the constraints? The first thing is environment. Now, this is a huge umbrella term, I know, but when writing a web app, we have a very well-defined audience that we can actually develop for. And if we're building embedded code, we actually have two different kinds of users. We have the person that's going to be consuming the code and pasting it on their website one way or the other, and we have the end users. And we can't make assumptions about what those end users really are. We want our code to basically be run everywhere. And that's pretty difficult, right? So yeah, it's weird. Next thing is file size. We really need to respect the end user's bandwidth and capacity to parse JavaScript. We also need to respect the website owner, right? So these are sort of no-brainer things, I know, but just something that you really have to keep in mind when you're running third-party code or making third-party code to be embedded. And browser compatibility. So again, if you can define your audience, you know their browser, but we can't really define our audience if we're writing code to be embedded in other people's websites. It's their audience. So browser compatibility is more about global trends. And yeah, so you're gonna have to support some probably older versions of IE that you don't want to. And a lot of authors of this third-party code that's being embedded, they use as an excuse to have poor developer ergonomics. So they're creating a giant single-file JavaScript that is hand-rolled to be ES5 compliant. And it's not maintainable, and it gets worse and worse over time. So network. You are likely being embedded in a page where there's a ton of network requests because they have 3 different analytics libraries that are all tracking clicks and they're all tracking the mouse movements. So something you need to keep in mind is you may be trying to perform a network request when there's a bunch of other network requests going on. So maybe we can do something. Maybe we can check to see how many network requests are going on and try to push our payload at a time where it's less chatty. So you're thinking you're going to write a little widget for general consumption, maybe an image gallery or anything. And, let's just basic stuff. I know you guys know this. Like, you don't need fonts, okay? Just use the host environment. Fonts are crazy. You don't need them. No global rules. Compress your images if you have them. Maybe even inline them. And in general, keep your file size low, of course. Okay, back to what we're talking about. You may be asking, okay, we're going to write some isolated DOM stuff, and we're going to style it. The question is, do I have an external sheet, or do I go with inline styles? And, well, okay. It actually doesn't matter so much, because the problems you're going to run up against are pretty much exactly the same. You're being sane, you're prefixing your styles, you're doing inline, and then you run across a global style. Like, this is going to happen pretty much at least 20% of the pages you're embedded on. Somebody is overwriting a div style, okay? And you're like, okay, well, maybe I can just be very specific about my style sheets and only I'll check for all these things. And then some reset comes along and it has like an important tag. And you're like, what about, okay, all right. So what can we do about this? What can we do about the global styles that resets are putting important on? And one of the things you can do is custom tags. And actually, this works in IE 9 and up, and everything else for the most part. It's not compliant with the HTML5 spec, but it's one way to get style isolation. In IE9, you actually need to create an element of the name before you actually use it. So here we just have a custom element called myWidget, and we're going to style it. We got style isolation for the most part. So we solved that, and then somebody's got an all element selector, and it's adding a border radius to your newly designed and style isolated widget. And you're like, okay, well, let's figure this out. So anyway, so we've got this, and what do we do about this situation? There's one thing that we can do, and that's to use iframes. Iframes are really the only way you're going to achieve true style isolation, and it's actually a good idea to run a lot of your widget inside the iframe anyway, because it's a little bit more respectful of the host environment. So yeah, I guess we're having some interface problems. But anyway, I'll just go on. So iframes, if you run a little bit of code on the host environment that then puts an iframe on the page that has the widget that's going to maybe run more code in the background, the browser can sort of deprioritize some of that code and not pretty much overtake the page. So let's figure out what's going on with this slide situation, and then I'll continue. This is the part of the talk where I say, how's everybody feeling? Get up and take a stretch. Well, you've maybe been seeing this crazy scrolling thing, and there's like a bunch of JavaScript CSS properties in there. So what we can do with iframes if we embed it, and we actually do this in Cloudflare apps page for some style isolation, is to put the iframe in the DOM, and then we apply our own sane defaults to it as inline styles, and we pretty much just take every single possible CSS property and put it on that iframe so that we can have a sort of expected behavior locally and on anybody else's page. Of course, there are still edge cases, but this does cover some of them. Which, okay. The iframe brings us to JavaScript, right? We're creating the JavaScript iframe and adding all those CSS properties. And yeah. So what are the sort of pitfalls and crazy stories? Well, first off, let's get the basics out of the way. And keep flashing my slides. Well, all right. I could just turn my computer around. Everybody can come closer. So anyway, let's get the basics out of the way. There's like some really simple stuff that I know everybody knows. Don't use globals, of course. We've known this for a while. But please, for the love of God, don't mess with the prototype. Don't depend on a library that messes with the prototype. Minify your code. Don't make a bunch of requests. If you have something that you need to phone home with, create a route that you can batch requests to, so you're only sending one. All right, so I mean, if somebody's on a mobile phone, the biggest problem is latency. And you know, if you're making a bunch of requests phoning home, just at least make a route that's going to be able to accept multiple of those requests. It's not too hard. And of course, profile your code, right? The biggest problem I feel like on a lot of these sites is they've included 47 jQuery plugins, and not all of them were very considerate about performance. So simple things. Another thing, if you're going to be copying and pasting or having a user copy and paste your script tag, consider putting configuration options within the script tag itself. I saw Stripe doing this with Stripe.js, and I was like, holy crap, this is a really great idea. And I've gotten a lot of great feedback from non-technical people. They say, like, that's all I have to do? I'm like, yes, that's all you have to do. So, little story about building the AMP viewer. If you can imagine a block of code here, and then imagine a scenario I put myself in, we'll be in good shape here. So we're building the AMP viewer, and the AMP viewer, actually, how many people are familiar with AMP from Google? So you know when you search for Donald Trump, and you're like wondering why I'm searching for Donald Trump, and you go to the search results, it's got the little carousel. Oh, look at that, Cloudflare. It seems to be extending my desktop now. You want to check that out? I guess it's in preferences. Or we can maybe move it over. Nope. Okay, let's check out preferences. Display. Yeah. There we go, mirror displays. Perfect. Okay, so I'll go back talking about AMP Viewer for real quick. So you click on a little miniature carousel in the search results. It's got that little lightning bolt, and then you instantly load the page. Google does this by pre-rendering the document or pre-rendering the document. They load it in an iframe in the background. They've got it on a Google CDN. And then when you click the article, it flashes into view and tells the AMP document to say, hey, you are now visible. You're now allowed to download images. You're now allowed to download your analytics tracking tools and actually start tracking. So that's kind of what the AMP viewer does. So anyway, I had some similar code as this, and we had already deployed it to thousands of sites, and we started collecting data. And one of the pieces of data we collected was that this list was undefined. And if you don't really have to understand the code, but the iterator function to the enumeration methods like map and filter receive 3 arguments, and the third is list, is the original list that you're iterating on. So why, in what scenario is list actually undefined? And the answer is when somebody overrides your prototype with an implementation of map that does not include list. And who does this? Well, Prototype.js actually did it before 2012, and they realized their folly in 2012 and released a new version. But there's still a ton of websites that use pre-2012 Prototype.js. What do you even do about that? How far do you go in not trusting JavaScript? And the answer is, for us, we went ahead and fixed it. We went ahead and said, okay, let's not rely on that variable because there's too many people that are relying on Prototype.js, pre-2012, I might add. So it's up to you. You really need to be collecting that data, though. That's the important part. And how do you do it? Well, we used Sentry. If you haven't used Sentry, it's really awesome, okay? I'm just going to kind of zoom in here. You get all kinds of great information. You get the browser and all the device and the breakdown of browser and the errors you're occurring. And you'll see here the stack trace comes in. And we're running completely uglified code. And yet, when the error comes in, we can actually see the line that had the error. And you'll actually see this is a TypeScript file, which we'll talk about a little bit later in developer ergonomics. So yeah, we have TypeScript, or we have Sentry error reporting. Now, we only run this for a sample of our users, so not everybody's going to be reporting errors to us. And it's a pretty easy thing to do. You just say like, hey, script, actually report errors to Sentry, or don't report errors to Sentry. So it's another thing about being a little bit responsible. You don't want every single one of your pieces of code phoning home for whatever reason. But there's a problem. If you've ever used Sentry, you know there's a library called Raven.js, which is a sort of embedded library of sorts as well. And they follow the pattern of a massive JavaScript file that is about 2,400 lines of code at the end of the day, and it's 24 kilobytes minified. And there's another XHR wrapper on the page, and you have to wonder how many XHR wrappers there are on any given website. So Raven.js is great. It does a lot of stuff for you, but it was too much for us. So what we did is we already had our own XHR wrapper. We already had the ability to parse stack traces. We just use the API, right? If we have access to their API, that we can go ahead and push all that error information, and we don't have that insane amount of code in our build. And what this really looks like is, you're hooking into the onError function on window, and you can't use add event listener error. I've already tried, but you can override this function and hope nobody else clobbers it as well. You also need to check to make sure that the file name that is coming through is actually your file, because there's going to be a ton of errors on the page, and you don't want to be reporting them all to your Sentry instance. So how do you get rid of those XHR wrappers? And one of the things we came up with and started experimenting with is just API fingerprinting. We live in a world where jQuery was this dominant library and still is, even though we rarely use it anymore as developers in this room. So, well, let's just look. According to some survey on builtwith.com, 89.5% of their top 1,000,000 websites use jQuery. And then their estimates for the entire internet is just under 20%. So you have a very, very high likelihood that $.ajax exists already. So what we should do is just start building little transports, little abstractions that make it look like fetch exists for everybody, even if they don't have fetch, and maybe they have jQuery. And yeah, it's a pretty good chance that they do have jQuery. What if they don't? What if they don't have jQuery? Try something else. These wrappers are really, really cheap, and then you have a nice XHR interface. So what if super agent doesn't exist, or prototype, and this embedded code is still running and relying on the fetch API? Well, you need to download it. Or you could say, like, oh, this code's not going to work, and I'm going to error out. But and you're like, oh, I have an 80% likelihood that my code will work. No, we can do better. We can actually just dynamically fetch polyfill, or we could fetch jQuery even, because they maybe even already have it cached from CDN.js. So we do that, but that poses a problem, right? We're fingerprinting synchronously to check to see if some code exists, and then if it doesn't, we have some asynchronous step that must occur. And in reality, we want an interface that just works. You pull in a module statically from your bundle, and you say, get me this resource, and you want to be able to just check the body, right? You want this. But in the situation where our dependencies may not have even been loaded yet, we need to queue up these requests. And once the dependencies are satisfied and the API has been defined, then we can go ahead and resume those requests. But to the developer, it should feel just like this. So we created a little library. It's essentially dependency injection, right? But it's a little bit different. So we just add these little decorators. And of course, the decorators are a little bit of fluff. They're not that much code to add into your code base, but you could just use the non-decorator API just as well. So we just let these functions know that we need the fetch API, and whatever the fetch API, that will be defined by us. And we also want to let it know that any calls to these functions should be queued up until the fetch API actually exists and has been resolved. So what does defining the fetch API look like for this? The first thing we do is, well, it's kind of, anyway, the same little library that we built. We're going to pull in the little definer function where we actually set up the dependencies, let it know what they actually mean. We pull in some strategies from this, from the other library, part of the library, and we only pull in the things that we're actually looking for, because our module bundler is going to do some tree shaking, right? And we're going to have as little code as possible. So we pull in these different strategies, and then we go ahead and define what fetch would be. And it's just a chain of these strategies. We're going to look for the built-in global fetch. Then we're going to look for jQuery's AJAX and wrap it. Then we're going to just say, okay, those didn't exist. We're going to load an external resource, wait for it to load, and then apply the jQuery strategy. I say jQuery because the user probably has already cached jQuery from CDN.js just from their internet travels. So that sort of takes care of that. What about performance tips? Those were, let's keep our bundle size down. Performance tips, I can't really say a whole lot that Addy already said and everybody else, and maybe even Jason, who's talking about Preact right now. But we'll go over a little bit of stuff. The main thing that I found was we don't want to negatively affect performance on the page. And we don't necessarily have to have the best performance, but we should probably queue our expensive actions. So with the AMP viewer, for a lot of our customers, there is this discovery step, right? And we're going to take all the links on the page and then check an external service to see if any of those links are AMP. And then we're going to modify the DOM with little icons that say, this is an AMP link. If you click on it, it's going to be really fast. And that's an expensive operation because we're calling out to a service and then we're modifying the DOM. So what can we do about that? And the thing we came up with to not affect performance on like initial load is to measure the FPS. And you can actually do that by using request animation and just kind of counting the frames. So measure XHRs, that's not super reliable. I'm not even going to talk about it. So some expensive operation just needs to be put on a queue and be deferred until later. And we can go ahead and just tell it, hey, when the FPS is at least 30, then maybe it's a safe time to go ahead and do this. We'll probably want to wait until other libraries have done their thing, and this will probably work. So developer ergonomics. Earlier I said that a lot of these embedded JavaScript libraries, they sacrifice a lot of the modern development practices that we've learned over the past few years in favor of creating a very small, tight, single JavaScript file. And I'm arguing that that will result in crappier code that will not be maintained properly. So just think about it. So for AMP Viewer, we're using TypeScript, as I said before. It's really great. It produces fairly small, tight code that's ES5 compliant. And we have a really great developer experience from it. So what does the AMP Viewer do? So this is what I was explaining before. A little BMW. Okay, well, it's just not going to work. That's cool. Well, let's try to go back and see if it does it. Well, whatever. Well, you guys know what I was talking about. It handles push state history API. It's got very smooth animations, and we're actually using a library called Preact. And Jason Miller is actually giving a talk right now about Preact. So it's a 3.5 kilobyte version of React, and it works really beautifully well. So we've got this on thousands of websites right now, and some of the builds are under 15 kilobytes, which to me still seems like too much. 3.5 of those kilobytes is Preact. So I'm pretty sure we can get this under 10 kilobytes. All the components, all the JSX, everything. And once I figure out how to properly mangle all my props using Clojure compiler, then I think we'll be in a pretty good state. So anyway, yeah, like I said, we've got this really beautiful component-based architecture. We're using TypeScript, so everything's checked statically at compile time. And we didn't really have to sacrifice the code in order to have a small file size. And also, module bundlers these days roll up in Webpack. I mean, they can export things to globals and just use function closures. So you're having really tight code that is just wrapped by functions rather than something like Browserify's little header file or header part that helps load the module at runtime. So you don't have a whole lot of overhead. And you can also export to multiple targets, right? The general consumption target is going to be to global, something that they're going to copy and paste that needs to self-register onto the page. It's just going to be a singleton that's exported to window, right? But so many times, like I've downloaded or I've tried to use an analytics tool, and they say the way to install this is you copy and paste this chunk of minified JavaScript onto your page. And I'm just like, why can't I npm install it? This is ridiculous. So I end up copying and pasting that into its own little module. So I'm not like, so it's all on my bundle, right? So it's so easy to just have a different target for your developers. You have an ES6 target and you say in your package JSON, here's my ES next entry point. And here's my main entry point, my widget. It's really easy to do. So use Rollup or use Webpack, please. And also export to global for the non-techies. So we've kind of gone all over the place. And I hope that you maybe learned a little bit from my travels. So please responsibly code and maybe try out the fingerprinting API. That should be open source pretty soon. And queue your expensive operations because, yeah, it's good for the world. So thanks.